All right, we are starting a new unit on weather and climate. So with weather and climate, this being a new unit, make sure you take your title page and you're going to put your new title page on page 123. We are going to go over the first three learning targets today. Those first three are, I can determine the difference between weather and climate, I can describe what determines climate, and I can define greenhouse gases and describe examples. So on page 125, I want your notes for these three learning targets. All right, first off, the difference between weather and climate. Weather is defined to be the atmospheric conditions, including temperature, precipitation, wind, and humidity in a particular region over a short period of time, either a day or a week. Typically when a meteorologist is on the news, he's telling you about the weather that is happening currently or within a day or a week. Typically they don't go out 10 days or more, otherwise it will be determined as not weather. Climate, however, is the average of the weather in a region over a long period of time, like 30 years or more. So we can tell generally in February of next year what the climate would be like because we can look at the past, what the past climates have been like. So you will notice that over time, it seems that our climate is changing, and we're going to get to that in the near future about why it's changing, why our weather has been so drastic as of late. So climate is what you expect. So like I said, what we're going to expect next February or next March, and weather is what you get. So what determines climate? The first thing that determines climate is the latitude. So looking at the region of the Earth that I have pictured off to the right-hand side, the higher latitudes are cooler. So looking up at the top, the North Pole, the numbers increase from the equator going up. So those lower latitudes around the equator are going to be a lot hotter. And we've learned this in the past just because of the direct sunlight that you're receiving. So these lower latitudes receive more energy from the sun because it's more of a direct hit rather than at an angle or reflected off. Also, how close you are to large bodies of water. When water heats and cools, it is different on land than what it is on water. Areas near water have more moderate temperatures, and then it cools much slower if it's on land. So it really determines on where that body of water is and how large that body of water is as well. A lot of times you might hear of lake effect snow, Chicago area, or even, let's say, Cedar Point region, because Cedar Point lies right on a big body of water. They get a lot of lake effect precipitation. Air and ocean currents. Warm currents raise temperatures, cold currents lower the temperatures. So looking at those air currents, we have currents that are in our atmosphere that you might have heard of before, but we also have currents in water. So when these warm currents reach the land, it tends to warm up the temperatures. And then obviously the opposite if the cold currents hit land. Also, where you are located according to some of the land formations. So just looking at this image that I have here, you'll notice that on the seaside, you're getting warm, moist air, so a lot of precipitation. And on the region of the rain shadow on the other side of the mountain, it's very dry air. So clouds lose their moisture as they go over mountains. So on the seaside, it has a lot of that moisture from the sea, so it occurs to have a lot of precipitation. But then on the opposite side, it's going to be very dry. Now, a good example of this in the United States is over in New Mexico area, Nevada. On the ocean side, there is a lot of rain that happens, but then on the opposite side of the mountain range, the Sierra Nevada mountain range there, it's desert-like conditions, and it's going to be 90 degrees all year, not very humid. So even when you go to that region, like I've been to Phoenix, Arizona before, 105 degrees every day. However, it didn't feel like 105 because they're so dry. They don't have a lot of moisture in their air because they are on the opposite side of the mountains. Here in Ohio, if it was 105 degrees, we wouldn't want to be outside because we have so much moisture in our air that it's just like sometimes unbearable. Also, altitude. The air is thinner and cooler at higher altitudes, so even regions, if you don't even think like the top of a mountain, there's places out west that they have their entire town or colleges in mountain ranges. And a lot of people, not just because of temperature, but because of the air pressure, sometimes it's harder to breathe when you're higher up and people aren't used to that. So the air is much thinner and cooler at these altitudes, and it really affects, I mean, it's much, much different because here in Ohio we are close to sea level, and to live somewhere that has an extreme altitude or a very high altitude is much more challenging, and you do tend to have cooler temperatures. All right, so greenhouse gases. A greenhouse gas is in the atmosphere that absorbs infrared radiation. So it's absorbing that radiation that comes from the sun, and then it emits it back towards the earth instead of letting it pass through into space. So instead of reflecting off, these greenhouse gases are trying to absorb as much radiation as possible, so that we kind of have this cloud effect over the earth, and it's warming inside of that big cloud that it's affecting. So water vapor is the most abundant greenhouse gas that there is in the atmosphere. Water vapor is basically the water that has been evaporated up into the clouds. So it mainly enters the atmosphere through this evaporation process. But you've probably also heard of transpiration, and that's just from the plants that have absorbed water over time. And now the plants, the water that is in it, is also getting evaporated up into the sky. Also, volcanic activity puts off a lot of heat, a lot of moisture, and so there is a lot of water vapor that comes from any volcanic activity as well. Our ozone layer is our protective layer that is around the Earth. So the ozone is in the upper atmosphere. Is very beneficial because it is supposed to block harmful UV rays. So ozone, if you look at the title, is O3. So it's 3 oxygen molecules that are binded together. Much different than what we breathe. We breathe in O2. So O3 is our protective layer. However, in the lower atmosphere, it is a greenhouse gas. So ozone can be a gas that is allowing the Earth to warm up. It is produced in a follow-up reaction when products of combustion are exposed to sunlight. So combustion from like car engines, when it gets exposed to sunlight, it goes up into our atmosphere and again has this layer around the Earth. Another greenhouse gas is methane. Okay, methane is a product of livestock farming. So if you look at the picture, that's where we get a lot of our methane from, is from livestock and the manure that they have. There is a farm that is just outside of Hicksville that does a lot of burning of methane, and it tends to stink really bad. However, they can turn this methane into a sort of energy. Also, when forests are removed, when they take down the lumber to make room for these cattle farms, this multiplies the greenhouse gas problem because the trees are there to be able to absorb these greenhouse gases and kind of clean our atmosphere. And when they take these trees away, that gives us more methane in our air. So methane is also released by landfills. If your parents take things to landfills, it's this digging process. So they're digging up the earth, then they're burying it. So they're basically reconstructing what's under our earth and causing a lot of the greenhouse gases to not be able to be absorbed because they're disrupting this process. Carbon dioxide, the amount of carbon dioxide in the atmosphere has been rising because of the Industrial Revolution. The Industrial Revolution, you might have learned about in history class, is just the boom of all these industries, these factories that are getting built to make life easier for us. So they produce fossil fuels by burning it to create their product. So because they are burning these fossil fuels, the carbon dioxide level increases, and then due to deforestation, these trees aren't able to absorb all of these carbon dioxide to actually replenish it back into the earth as a positive way. So the deforestation, since trees store carbon from the atmosphere, which is called carbon sinking, can cause these greenhouse gases to get into our atmosphere. Nitrous oxide is another greenhouse gas. Agriculture, farmers, they overuse fertilizer sometimes, and these fertilizer, if you look at this picture, they spray or fertilize their crops, and not all of this gets into the plant itself. And just like I was telling before about transpiration, that natural water cycle process, transpiration, that water gets evaporated, or the nitrous oxide gets evaporated up into our atmosphere. So we all have all these bad chemicals that are just kind of sitting there. And so our atmosphere isn't able to protect us because of the bad chemicals that are causing it to create a hole. Chlorofluorocarbons, the CFCs, tend to come from aerosol sprays, refrigerants. They are not only greenhouse gases, they are also responsible for the hole that is in the ozone layer. So it was back in the late 1900s when somebody finally realized that, hey, what we are doing here on Earth is really causing some problems with our atmosphere. So we're getting a lot of sunlight that's coming in because there is this hole in the atmosphere. Now, the hole isn't near where we live, so we don't get direct effects. However, they do feel like this hole may have caused the global warming effect. So since they've realized that these aerosol cans and refrigerants have been causing problems, the CFCs have been banned in many countries. Not here in the United States, however, we still are able to use them. However, we need to be very cautious with how much we use them. So between hairsprays and aerosol paint cans, so over 200 countries agreed to cease production by 2030. So by 2030, so just in a mere 11 years from now, the CFCs or the aerosol sprays are not going to be allowed just because this hole is not getting any smaller. All right, so we went over the 3 learning targets. So I want you to go and answer the 3 learning targets in your notebook, and then we will go over those tomorrow. So this completes the podcast over weather and climate.